Hello, everyone. My name is Shuping Xiong. I'm currently a professor at KAI's Department of Industry and Systems Engineering, directing the human factors and economics lab. Now, let me give you a brief introduction to our lab. Our lab is named Human Factors and Economics Lab. The major mission of this lab is to improve human safety, health, comfort, and performance. We performing both basic research to understand human capabilities, limitations, and how they interact with the other system elements. At the same time, we also promote applied research to design human-centered technology and system for the human well-being. We are particularly interested in the following four focus areas. The first one is technology and health aging for the safety and health of the aged populations, especially about their fall risk and fall-related injuries. The second focus area is related with human-computer interaction. We are very interested in human interactions with virtual objects in VR, as well as how humans interact with exoskeleton, as well as human robots. The third research area is on human biomechanics, behavior, and performance. We're very interested about data-driven modeling of human behavior and performance. The fourth focus area is digital model and their applications to economic product design development, especially about wearable products to improve their fit and comfort. Let me introduce those focus areas one by one. So this slide lists out the major detailed research contents for each of the focus areas. Due to the limited time, I will skip the details. Instead, I will show you some of the representative research projects and achievements we made for each of the focus areas. For the first focus area, which is technology and health aging, we have conducted several research projects in the past 10 years on elderly people's fall and injury prevention. We developed a suite of technology ranged from fall risk assessment diagnosis to tailored interactive fall intervention. And recently, we also developed full status monitoring and injury prevention technology. So let me give you the detailed description of each of the technology we have developed. For the first technology, which is ACT-based fall risk assessment diagnosis, we're utilizing 5 wearable electric sensor and 1 mobile application. Then based on testing protocol, we can identify the high-risk individuals with accuracy up to 89%. And if one elderly individuals, they was identified as high fall risk individuals, we can also provide them the preliminary diagnosis report, which to show what are the strengths, what are the limitations, so that we can further share this report with the doctors for the in-depth examination. So the detailed study, you can look at our published results as well as our registered patent. For the home-based tailored interactive fall intervention system, we developed a system which can support elderly people at home or in the community to improve their balance and minimize their fall risk in the future. So here we're utilizing a depth sensor, which is a Kinect depth sensor, to track their motions, track their skeleton, and we developed different kind of modularized X game. So some of them focus on their cognitive capabilities and memory. Some of them focus on their apnea and knowing strength. Some of them focus on their integrated the balance capabilities. So during the intervention, there's a virtual coach which guiding the elderly individuals to performing the fall intervention at home by themselves. And their performance was real-time tracked and evaluated through our algorithm. And the typical level will be automatically adjusted according to their performance. So this the X game itself, different modules, they will be intelligently configured to suitable for the elderly individuals based on their the risk level and also the underlying risk factors. We utilized this system and we conducted a large-scale test. We found out that after 2 months of training, so compared with the control group, the intervention group, after utilizing our system, there are major parameters for human balance and fall risk have been significantly improved. So the details, you can also look at our recent publications. So recently, we also developed AI-based smart airbag to continuously monitoring the fall status of the elderly individuals and prevent the injury in case the fall accident happens. So we first built one of the largest data set in the world, and then we built a hybrid deep learning algorithm, then further embedded this deep learning algorithm in a wearable airbag, so that once the fall was initiated, our system, our algorithm will be detected in time and then trigger the airbag so that they can be fully inflated to protect the injury when the body comes to the ground. So this is very wonderful collaboration project with Professor King at the Yale University. So we also published many papers regarding the related research. For the second focus area, which is human-computer interaction, we are very interested about how humans naturally interact with virtual objects in VR environment. So when we interact with virtual objects, the interaction itself is fundamentally different when humans interact with traditional workspace or computers, because we're lack of haptic feedback. At the same time, our hands have to hold in the hand controller, for example, to shoot the rain, to interact with the virtual objects. So this kind of interaction is very difficult when the object is far away from us or object itself is very small. So at the same time, because hands have to hold in the hand controller, so this kind of experience itself was not very natural. So to overcome those challenges, we have developed different technologies to support the natural interaction between human and VR. So first, we developed a viewfinder VR to bring the distance objects close to us. And after that, we further developed super haptic features to providing haptic features through the design, innovative design. So we utilize this kind of proximity, feedback, protrusion, heat effects, so on, so that we can, generate it, similar as haptic features. And we also further developed haptic VR keyboard, so that we can improve the middle text typing performance as well as user experience. So the details, you can look at our publications in the leading journal in the field of human-computer interaction as well as virtual reality. Here, I also want to mention that aside from supporting the distance interaction, near interaction in the virtual environment, we also develop technology which can support natural locomotion in the virtual environment. So that is about one of the representative projects in the field of human-computer interaction. For the third research field, which is related with human biomechanics, behavior, and performance modeling. So we first built somewhat simplified biomechanics model to analyze the risk of developing muscle scan disorders in terms of when the workers working in for certain different tasks or with different methods. And we further improve our model to add in the muscle to be more realistic. So we built a muscle skeleton model. So adding the muscle, we're causing the problem become much more complicated. So this we're causing so-called interpolation problems. So to overcome this problem, we have to utilize the optimization strategy to build this kind of muscle skeleton model. And we can further utilize this kind of muscle skeleton modeling approach to evaluate the human, when they interact with the other wearable technology, for example, exoskeleton or wearable robot, to check about if the human utilize such technology. So what are the potential risks? What are the potential benefits the human user will gain? So this will be able to help us to performing the evaluation at very early design phase. And at the same time, we can also optimize the design process. So recently, we also are working with our industry partners such as Samsung Display to further develop smart technology to supporting industry safety. So we're utilizing computer vision or IoT device to develop intelligent solutions. For example, we're utilizing computer vision to detect the human walking posture and to assess their risk to have ergonomic risks such as muscle scan disorders. And this one is that we develop computer vision-based technology to automatically detect whether the workers they are wearing the personal protection equipment, for example, the helmet or the lifeline and so on. The fourth research area is related with digital modeling and economic design. So we are interested to develop different kind of digital model and putting those digital model into the product design and evaluation process. So for example, when I was working as a professor at Xiang University, we developed a 3D system which can customize the shoe nest based on the customer foot features as well as their preferred style. So basically, after quick scan of the customer foot, we will be able to extract their foot features automatically. And then based on their preferred style, shoe style, then we can have a very rapid customization process so that we can customize the shoe nest, which maintain the customer preferred style, but at the same time to improve their fit and comfort. So this shows some of the important steps. So we first build a digital model of foot, and then we utilizing the optimization to deform the shoe nest. We have global deformation and local deformation together. And then later on, we also simulate how the foot was put inside the shoe nest, which part is tight, which part is loose. So we utilize the virtual fit and comfort evaluation and visualize it utilizing the color code map. So to see which part, for example, is loose, this one is tight, so that we can support the rapid product customization with better fit and comfort. So over the past 15 years of development, we have our lab has been equipped with many advanced research facilities to support our students to performing various kind of research in the field of human factors and economics. So basically, you can say that we can capture almost every information about human in terms of their motion, in terms of their body size, shape, in terms of their muscle actuation, their attention, in terms of eye movements, and also their brain activity and so on. So currently, we have 12 full-time research members. And in general, every year, we also have 4 or 5 research interns as our research assistant. So I'm lucky to work with our research team because they are very active and productive. We not only conduct various research projects, especially the multidisciplinary research project, but also we publish very actively. So our research paper has been highly cited by the peer researchers. Our research team also won many research awards. For example, the best paper in Applied Human Factor Economics Lab, Economics Society, and International Economics Association, and ISOES, Chinese Economics Society, as well as the first prize in Informs. Our research has been highlighted by various kind of media, and we're proud that our research team was had strong global presence. in terms of edit board members for 6 international essay journals, as well as very wide international collaboration network. We are working very hard to create an excellent research environment for our NAP members. As mentioned before, we not only have a state-of-the-art research facilities and NAP space, so we also have modernized student office to support our students' research progress. We have a regular research meeting between students and professors, as well as the students and student meeting within their own research group, so they can support each other and learn from each other. And we also have monthly NAP gathering and fancy dinner out of campus. So we're actively supporting our students to attending academic conference to share with their research achievements. We also have a birthday party for every members, as well as kind of workshop. So far we have 25 successful graduates. And among those PhD graduates, so half of them have been a university professor right after their graduation, and another half working as research fellow at a leading research institute or technology company such as LG or KT. So for the master graduates, so typically they work in industry as industrial engineer or researcher, or product engineer or researchers. Some of students also working as AI engineers. So another half of our master graduates, they continue the PhD study at KAIST or in the other leading overseas institute. So basically, this is the end of my short introduction. If you want to know more details, you're welcome to contact me or our student representatives. Thank you very much, and have a nice day.